Welcome everyone, Konstantin, carhs Training, and this is episode 2 from the SafetyWeek Preview. This video series features selected content from automotive safety from presentations given at the SafetyWeek in September. If you want to rewatch this episode or the previous one, please make sure to check out our LinkedIn company profile. Today, let's talk about active safety. NCAP is continuously implementing new load cases in their safety assist category. Crossing and dooring scenarios are a challenge to achieve maximum test scores. A majority of Germany's NCAP tests are done by the experts at the ADAC. Andreas Rickling is in charge of the active safety testing program there, and I'm happy that he joins us today to talk about these new load cases.
Hello from ADAC Test and Technical Center in Landsberg am Lech. We are still in lockdown, unfortunately, but I'm really looking forward to meet you again on Safety Week or other congresses. Today I can introduce you in some new Euro NCAP scenarios regarding active safety. We're here in the crash facility, but I'm going to talk about car-to-car scenarios from 2023 on in Euro NCAP. Back in 2017, ADAC did the first test on crossing and junction assist. We had 3 cars. It was a Volvo and a Audi. Both models addressed the front turn across pass scenario that we are testing from 2020 on in Euro NCAP. So it keeps your ego vehicle, the VOT, from crashing into oncoming traffic. And one model already had, it was the E-Class from Mercedes, had a junction assist that could avoid the contact or the impact with a crossing vehicle in orthogonal 90 degrees direction. And this is one of the biggest changes we are going to expect in Euro NCAP 2023. It will be 4 points for the AEB crossing junction scenarios. 4 points will go to the scenarios we know nowadays as car-to-car rear. We are performing them for long. There will be one change, the FCW points. They will decrease and more proportion of the points will go to the AEB scenarios. And another 4 points will be available for the car-to-car crossing scenarios, the junction scenarios. The junction scenario, the 4 points, 1 point of them will go from 2023 on still to the front turn across pass scenario that we are doing now. It's overall 9 tests because we have 3 different speeds of VOT combined with 3 speeds of the GVT. And the only real change that we are going for 2023 is a bit of a higher speed in the oncoming GVT. So it will probably drive 60 kph, the oncoming one, instead of 55 as we're doing nowadays. So those 9 tests will get 1 point. So 3 points are available for the crossing scenarios, orthogonal direction, what the E-Class already addressed back in 2017. So, what we are talking about is a quite big matrix of tests with different speeds. It's 5 and 6 rows, 5 GVT speeds from 20 kph and 10 kph steps up to 60 kph. And for the ego vehicle, for the VOT, we will start from standstill, going then to 20 kph and further in 10 kph steps up to 60 kph. So this will give a matrix of about 30 scenarios, and the maximum of points will only be available when you can, let's say, swap the positions. So any speed at any target or GVT. What we've seen with the first systems that addressed those crossing accidents with the Daimler back in 2017 was that it was limited to a GVT speed that was only about the half of your ego speed. Why? Because the sensors, they were really narrow, and what we are requesting from 2023 on will be systems that have wide-angle sensors or even corner sensors that are able to detect faster crossing vehicles. So those will be the most challenging scenarios, 60 kph GVT speed to maybe an even lower ego VOT speed. So the worst case would be a standstill VOT that needs to detect a GVT or a crossing target that comes with 60 kph. You definitely are going to need a wide angle sensor, and it's not only about the sensors and the platform that needs to be capable of doing this scenario in speed and also in perfect synchronization. By the way, the eVate project came up with a lot of possible varieties and scenarios: hit car to the side, hit car to the front, or corner to corner. And the plan that Euro NCAP has at the moment is bringing it down to only one scenario, that is corner to corner, and we are assuming symmetry, so you can swap any direction and always are hitting corner to corner. So it's not only the wide angle sensors that I was mentioning, it's also the test track length and width especially that we are going to need in the near future. So if we are performing a crossing scenario with a 60 kph GVT, taking into account it will have about 100 meters of acceleration phase, calculated with a 1.5 acceleration. Maybe some platforms are capable of reducing this space because they have faster acceleration. But calculating that, you need 100 meters, then you will have a steady state at 60 kph, which easily is for a 4 seconds steady state, 60 meters or even above, and afterwards you need a deceleration phase to get it all safely to a standstill. So we are talking about a track length to the side of minimum 200 meters to perform those high-speed crossing scenarios. This will be quite challenging next to the platforms we are having available by then. So this was only a very brief introduction. The crossing scenarios might be the most challenging for car-to-car testing that we are expecting in 2023. And I hope to see you again in person as soon as possible. And I hope you are so far all safe and stay safe. Thank you. Looking forward to the next Congress.
All of these scenarios require robust, high-tech equipment. Let's hear from Gianmarco Maccaro from Humanetics about the latest updates on their ultra-flat overrunnable platform. Humanetics will also join us at the Safety Week as a sponsor and exhibitor.
Thank you, Andreas, for this really interesting presentation about the new testing scenarios that are going to be tested within Euro NCAP in the future. As you for sure know, as Humanetics, we are offering a wide range of active safety testing robots. Firstly, you can see here on the screen our UFO Pro platform. This platform is designed in order to carry around the global vehicle target on the test track. Below, you can appreciate the UFO Nano platform. This platform is engineered in order to carry around vulnerable road user targets on the test track. On the left-hand side of the UFO Nano platform, you can see our driving robot. Our driving robot can be installed in the vehicles in order to replicate the inputs of a very accurate human driver. On the top of our robotic solutions, we offer a control and synchronization software. But now, I would like to guide you through having a look at the performance of our UFO Nano platform and how this solution can enable you testing scenarios from new testing protocols. looking at the UFO Nano platform driving on the test track, you can immediately notice the two main characteristics that makes it the obvious choice when it comes to Euro NCAP testing, as well as when it comes to new test cases. Firstly, you can notice the ability of performing two-dimensional maneuvers. The turning radius can be narrowed down to 0. This means that the platform has the ability to turn on the spot. Secondly, you can notice in the video that the width of the platform is extremely compact. The whole footprint is just 80 per 70 centimeters. So the width is just slightly more than the width of the shoulders of a typical human. Lastly, we have a unique split design. This means that the robotics are contained in the extremely compact upper part of the platform, and the vulnerable road user targets are standing on a passive appendix. Looking now at two UFO Nano platforms driving next to each other on the test track, you can understand the vision of Humanetics. On the one hand, we think that swarm testing will involve vulnerable road users. This means that the unique footprint plays an important role, allowing the pedestrians to walk hand in hand. Secondly, the unique footprint allows the UFO Nano platform to drive as close as possible to other objects on the test track, such as other vehicles. This plays an important role in scenarios like the dooring scenario that Andreas just described, in which a bicycle target can drive as close as possible to the vehicle under test. But for future proving ground testing, vulnerable road user targets will not be the only ones involved. Vehicle targets will still play a very important role. This is confirmed by the crossing scenario that Andreas just described, that will be now introduced also by Euro NCAP. For those kind of scenarios, the Humanetics UFO-based control and synchronization software guarantees a unique characteristic. It is possible to change the master triggering vehicle. This means that the test can be triggered either by the vehicle under test or by the UFO platform. These characteristics allows you to save a lot of space on the proving ground. But let's take one step further ahead from traditional ADAS verification and testing protocols. How do we see autonomous vehicles being tested in the future on the proving ground? For this, traditional approaches of open loop scenario control on the test track might not be enough anymore. We might want UFO platforms and driving robots to take their own decisions. And those decisions should be based on the behavior of the vehicle under test. For this, Humanetics came up with the unique UFO-based script. The scripting of the scenarios allows closing the control loop on the test track. Thanks to this new feature, the testing of autonomous vehicles is now enabled.
This is it for today. Thank you for watching and make sure to tune in to our next Safety Week episode.